Hi, I'm Alan Ross, and this is another EPRA Take 5. My guest today is Ben Lanz of IMCORP. I met Ben over a chicken wing at the NETA conference, I think last year. Was that correct? Isn't that what we were doing
At
back
least a
then, Ben?
year ago. It's
Yeah,
been a
I think
long
that might have
year.
been the last one we did. I mean, any of us did, right? So, Ben, here's a question, and this is going to be a Take 5 series because you can't answer the question in one Take 5 to 6 minute session. So we're going to set it up as a series, but it is an overall question that as I've looked at the reliability of industrial, commercial, and even grid edge sites, that I've seen a major problem out there, and it's the reliability of cable systems. So if you were responsible for the reliability of a cable system in an industrial or commercial facility or any kind of a facility, and suddenly you got the job, you're hired day one, Ben Lance, what would you do?
Well, I would look for an opportunity for education to quote a educator and teacher and author that's at the top of my list. Stephen Covey, the late Stephen Covey,
Seven
mentions
great
that.
habits of successful people, right? The 7 habits of
That's right.
successful people.
7 habits, right? That's right. He says to begin with the end in mind, and I really believe that. We're trying to make sure we understand what the issues are and make sure that we're educating ourselves. And one of the best opportunities to educate that we've found is when a plant is going through perhaps a scenario where we're going to upgrade some equipment, we're going to replace the cables, or maybe just the cables themselves are of a certain age and someone's going to replace that. That is a perfect opportunity for education, because what we can do is we can get in there, make sure that the teams are trained on how to install cable, how to install the accessories, the science behind those components, and perform a factory comparable partial discharge test, a commissioning test that provides a foot-by-foot profile of that system. And once we have that, very often, and about 25% of the time, a three-phase system will have substandard components, which is an opportunity to dig in, find out what the problem is, and learn from that experience. And when someone can see what a defect looks like and starts learning of what to look for, understanding what defects look like and how cable systems fail is a key element to understanding the best principles for design, installation, and even maintaining. So that educational opportunity, if I needed to start somewhere, that's where I would start.
You know, I know there's a failure modes effect analysis that is part of the IEEE body of knowledge. Are there any places where a failure modes effect analysis where you can determine what components fail, what for the cable system? Is there any IEEE or other work done on that?
There's been quite a bit of work. Most of the information resides in technical papers, but there are some IEEE documents, standards, if you will, guides that go through some descriptions of the failure mechanisms of cables and accessories. And those are available through the subcommittee, Insulated Conductors Committee, ICC of IEEE.
Okay. And that, you know, if you're not an IEEE member, one of the things that we're trying to bring to the forefront is that information is a standard. Typically when IEEE publishes it, it becomes published as a standard. It becomes a peer-reviewed industry standard. And if your committee is anything like the Transformer Committee, there's a lot of people doing a lot of work on that. So you mentioned something about the education of getting people to understand where they see substandard assets or where they see defects. You don't have to explain all of them, but if you could pinpoint one of the either most from the standpoint of frequency or most from the standpoint of consequences, which is the most or the worst, the most important, the worst defect that somebody should be looking for?
Yeah, a lot of installation educational seminars will focus, if it's put on by a manufacturer, they'll focus on the product. Rightfully so. They're showing how the product is easy to install. But one of the most critical steps is the cable preparation before you put the device on. And that is often what's overlooked and misunderstood. The stresses Often when you say, where's the worst part of this, or where's the most critical part of this termination, people often point to the connector. And the connector is an important part, but it's not the most critical part. The most critical part is actually closer to the base of the termination, and that's often overlooked. That's the most critical area, where the outer layers end and the insulation begins underneath the termination.
So my assumption is there's standard testing protocols, that there's equipment, and that's what IMCORP does. I know we will be sharing at some point a case study that you shared with us that was, I think it was a utility in Houston, if I'm not mistaken, where you saved them millions of dollars. And it was because there's technology, there's equipment, and there's process and procedure to obey those standards. And I'm sure over the next couple of Take Fives, we're going to cover a lot of them as it relates to the typical industrial commercial reliability program, which is nascent. This is not something that's been out there, and we do think it's a system. Cables connect every other component of the system, hidden and seen. You remind me of that all the time. But when I say that, when I say the cables are the connectors to all of the other assets in the system, if you were giving this group again, who you're now in charge of, and you're coming and saying, I'm bringing cable reliability to it, talk a little bit just for a minute about how you think cable reliability connects with electrical system reliability.
Yeah, so one of the big areas of overlap is how the system really treats the cable. Most modern cables are plastic and rubber materials. And just as I believe was one of the professors, was it Dr. Bob that we talked to down in
Dr. Bob
Genesis?
Hebner.
Yes. And he mentioned that voltage transients, so really power quality, the quality of the shocks that the system is receiving, not only for high current, say if you have a connector that's overheating, but the voltage transients impact the reliability of, sometimes if you have a tape shield style cable system, or even the dielectrics inside, those systems do not handle high stresses very well, especially as they age. So one of the big overlaps of how cable systems interact with the rest of the system is if you're having lots of switching events and overvoltage events, even just microsecond, millisecond timeframes can actually start eroding material away. So if you have a defect, it can make it worse, but in extreme cases, it can actually create new defects that didn't exist before.
Yeah. Okay, we have a lot to talk about in cables, but this has been a Take Five with Ben Lanz. He is one of our advisory board members, and IMCORP is a research practitioner as part of EPRA. And what we're trying to do is to bring knowledge, understanding, to equip you, to educate, and to inspire you. You inspire me to think about cables as part of the entire electric power reliability program. So thank you for your support, Ben. Thank you for being part of this. And we will chat again.